Good morning, everybody. Before we start the talks, I just want to introduce Jenny Capon, who's just on the wall over there. So she's an artist and visual note taker, so she'll be drawing beautiful pictures throughout the day as sort of a visual note-taking type thing to sort of visually encompass the talks and discussions today. So please do go to Jenny and have a look at her art throughout the day, especially at the end when it'll all be sort of almost complete, I think. So today's first session is just 1 hour, and it's going to be 4 mini talks by people from EPIC on EPIC for impact using data-driven innovation in research. And each is a 10-minute talk, and then at the very end of all 4 talks, we'll then have the questions and discussion. So we won't have questions after each talk. And the first is Giles Innocent from BioSS, and he's talking about where have all the cattle gone. Over to you, Giles.
Yeah, with apologies to Joan Byers and Peter, Paul and Mary and Marlene Dietrich, yeah. Okay, so there are issues with data, with real data. So data are not necessarily perfect, and in particular, the data we're looking at, and I'll go into this in a little bit more detail in the next slide, they're not perfect spatially, and they're not perfect over time. Perhaps more importantly for us, for the reason why we're looking at this initially, are data protection issues. So when we have data, real data, which identify individuals, and farm locations are deemed to be an individual, okay, so we can't use those. We have restricted access, and good policy says you should only use it if it's absolutely necessary, and where you can avoid using personal identifiers, you should. Furthermore, it means that we can't just give those data out to anyone. So that's an issue if I want somebody else to test my code. It's an issue for peer review. So, what's the present gold standard? I hate that phrase, but we'll use it today. So in the event of an outbreak, we would be expected to use real data, and there's no doubt about that. That's not an issue. We have a reason for accessing the real data. We'd be using farm census data or data from the cattle tracing scheme, because that's the way that you find out how many cattle there are on a farm. The problem with this is that we locate all those animals at a point location, which is typically the farmhouse. Whereas those animals are in fact spread out over an area of land, which is the farm. And as we'll see, that may be, in certain circumstances, quite important, okay? We also assume that we know exactly how many animals are there, ignoring the fact that the number of animals there yesterday may not be the same as the number of animals there today. And in particular, if we're using the farm census data, that's how many animals were present on that farm on one day. And that might be the day when they've just bought in 100 extra head of animals and they're going to sell 100 tomorrow to compensate for that. It wouldn't be tomorrow, but next week. But we assume that that number is the number of animals on the farm at any point in time. And obviously, even if we're using the cattle tracing scheme, which should be up to date, there's always delays in the data coming in. So it may be that it's actually it's a week out of date. And that may be important in some farms. So we want to move away from, where we can, we want to move away from using the precise, supposedly precise, real data, to moving towards some sort of abstraction from that, which might be more relevant and more realistic. So these are This is real data, by the way, and I don't have to worry about GDPR because there's no way you can tell where those farms are because they're shifted, they're rotated. So they're anonymized in a different way, but not perhaps a very useful way, but useful for me when I'm doing this work. And what you can see there is that's what we say at the moment. We've got a number of farms. There's 10 on there, I think, or maybe, yeah, 10. The light colours have got more animals, darker colours have got fewer animals. That's what we think is reality when we do our modelling. But in reality, it looks more like what's on the left. So those are imputed parcels of land, don't worry about it. But those might be what the farm sort of looks like. And each one is coloured by how many animals are on that farm. But actually, it's not the whole area. The animals are probably in a field or in a barn or something on the farm. And so what we should be looking at is something closer to being on what's on the right. And what you can see at the bottom there is we've got two farms where the farm houses are quite spatially distant, but the animals are right next to each other. And there are some where the farms are quite close, but the animals are quite distant. Okay? So using the farm location, the farmhouse location, as the location for all the animals is not necessarily particularly useful. So, in an ideal world, we want our data to look something like the real data. So there should be some sort of spatial equivalence, if you like. Whatever that means, I'm doing a lot of hand-waving at the moment because we haven't defined what that means. And what it means is, do the models give us the same result or similar results? So it should have the same form as the true data. So in other words, if you want data on farms, then I should be able to, if your model runs at the farm level, I should be able to give you data on farms. If your model runs at the animal level, I should be able to give you data on where the animals are. It should be spatially analogous to the true data. In other words, if you look at how far apart farms are, they should, look at a distribution of how far apart farms are, they should look the same with our synthetic data. And it'd be really nice if we could have multiple data sets so that we could run our model multiple times on slightly different data sets, which all mimic reality, but maybe look slightly different so that we're not fixed on a single value of what it was last May or whatever. So we can look at, are these results robust? It'd be nice so that if we didn't have personal identifiers and no way to link it back to personal identifiers. And then we would be free to give the data to whoever we want. So what we're proposing to do, what we have on the left there is a sort of a smooth surface which says this is where animals are. This is a sort of density map of animals in 2 dimensions. And then we say, well, okay, given that density map, can we say where the animals are? And we can do that for farms as well, so we can have a density map of farms and say, this is where the farms are. This is where the most dense areas for farms, and therefore this is where we impute where farms could be. It's not where they actually are, it's where they could be. And then we can associate each farm with a number of animals, and we get back to something that looks very similar to the true data, if you like, the original data, that we were expecting to see. So the question arises, is this actually better? Well, I think so. Otherwise, I wouldn't be doing it. It has certain advantages, so it's less dependent on actually what data are there. It doesn't matter if they, if I manipulate the data and I move 100 animals out of a farm, it's not going to look very much different what I produce. okay? And that's quite important, so it's more robust to changes in the number of animals. It's more robust to animals moving, not being associated all at the point of the farm. And there are no data protection issues, okay? Which means that if I generate a number, let's say 100 of these data sets, I can leave them on a server somewhere, and everybody within Epic can use them without having to go through all the hoops that are required by GDPR to access real data, if you like, with personal identifiers. We can also share it with other people out with Epic. Okay, here's the caveats, if you like. Firstly, we're going to have to do a lot of testing on this, and in particular, what we're going to have to do is run models on, if you like, the real data, and then models on our imputed data, and see, do we get similar results? And I'm, at the moment, don't know what similar means before anybody asks me, because that's the obvious question, and I don't know. There are a number of metrics that we could use that would define them as being similar or dissimilar, and it partly depends on what use you're putting your model. Okay, so if you're just interested in will we get an epidemic or not, then we can look and see, well, do you get an epidemic, and how big is it? But if you want to say, well, is it important where they come into Scotland, where infection is introduced into Scotland, then we have to look and see, do we pick up on regional differences? And that's, does it work? Is it worse than the status quo? In other words, reality as we see it at the moment is that all animals are at the farm. Well, that's not right either. So we could actually say, well, actually, let's look and see what happens if we put animals, rather than at the farmhouse, we put them somewhere. Yeah, I know, this is my last slide, don't worry. We put them somewhere on the farm. Can we work back from animal to farm? I think I can. I've worked out how to do that yesterday. Should we change models to work at the animal level rather than the farm level? That's an interesting question that perhaps modelers should think about. Other methods are available, CMAP for one. We think that for various reasons they're not suitable for our needs. There we go.